Hi, welcome to Tesla Car World. In today's episode, we're going to talk about the Cybertruck, arguably the most controversial vehicle in Tesla's lineup. The truth is, Cybertruck sales are alarmingly declining this year. The company has sold only around 10,000 units so far, compared to about 40,000 units last year. Is the demand for this vehicle practically collapsing? What do you think about the fact that many people aren't buying the Cybertruck simply because they don't have enough space for it? As we all know, people partly dislike the Cybertruck because of its bizarre design. It's quite large and bulky. But the biggest factor behind the drop in demand is its price, which is far beyond the reach of most customers. Even the cheapest version costs nearly $70,000. Design and price are the two main issues keeping demand for the Cybertruck consistently low. And if this trend continues, there's no doubt that the Cybertruck could become the product that contributes most to Tesla's potential risk of bankruptcy. Look, we're big Tesla fans and got a soft spot for the Cybertruck, but let's be real here. Tesla's not just going to sit back and let the Cybertruck flop, and they sure as heck aren't going to let it tank the company. To make the Cybertruck something most people can actually afford, Tesla just dropped a smaller, cheaper version that costs about the same as a Model 3, or even less at $49,990. So, what's this new version got? How'd Tesla strip it down? Let's dive in and find out. Yeah, the Cybertruck's design might stir up some debates, and the price tag's been a tough sell for some. But when it comes to the driving experience, durability, and keeping drivers safe in serious crashes, we'd bet good money the Cybertruck's in a league of its own. Here are a few random comments from Cybertruck owners we stumbled across. Yeah, that's something we can't deny. The Cybertruck does offer features you simply won't find on other Tesla models, like steering by wire. The interior also delivers a premium experience with a central control screen as large as 18.5 inches. However, its high price tag makes all those specs and driving experiences almost meaningless for most people. They just don't get to enjoy these amazing features because they don't have the chance to own such an expensive pickup truck. But price isn't the only issue with the Cybertruck. Currently, Tesla's pickup is only available in North America, not in major markets like Europe or Asia, where Tesla has a significant presence. The main reason is its oversized dimensions, which simply aren't ideal for many narrow streets or varied traffic conditions abroad. Earlier this year, the UK government confiscated one of the first imported Cybertrucks, while another unit in the European Union had to be modified to meet local safety regulations due to its sharp, rigid body design. The truth is, Tesla actually downsized the Cybertruck before starting production and deliveries in November 2023. The original prototype was slightly larger. From what we understand, the size reduction was partly to ensure the vehicle could fit inside Boring Company tunnels. But clearly just shrinking it a bit wasn't enough. For the Cybertruck to make it into markets beyond North America, Tesla really needs a significantly smaller version, and the price needs to come down even further. There's nothing more important than price, and that's exactly why the company decided to develop a smaller version, as confirmed by Tesla's Vice President of Engineering, Lars Moravi. He stated that Tesla will launch a compact pickup, possibly as soon as next year. In fact, Lars Moravi isn't the only one who's talked about it. Elon Musk also hinted a smaller Cybertruck version back in 2019. He teased on X that a smaller version of the Cybertruck could be released in the future. So what's in a smaller version of the Cybertruck? First and foremost, the size and weight of this new version will be significantly adjusted. Although the current Cybertruck comes in multiple motor configurations, it's only available in one size. With an overall length of 223.7 inches, a width of 95 inches, and a height of 70.5 inches. The bed measures 72 inches long and 48 inches wide, while the truck's weight ranges from 6,000 to 6,900 pounds depending on the motor variant. However, the smaller Cybertruck is expected to shrink down to dimensions more in line with mid-size pickups like the Ford Ranger or Toyota Tacoma. Specifically, the new version will reportedly reduce overall length from 223 inches to around 210 inches, and width from 95 inches to just 75 inches, while maintaining the same height. The wheelbase is expected to drop to about 135 to 140 inches, making it more maneuverable in tight spaces. Thanks to its air suspension system, ground clearance could still be maintained at around 16 to 17 inches, ensuring solid off-road capability. Of course, the new version of the Cybertruck won't retain the same sharp, angular exterior as the original design. Instead, it's expected to feature more rounded and streamlined lines, similar to the look of the Ford F-150 or the Rivian R1T. That said, it will still carry Tesla's signature modern aesthetic, thanks to the use of stainless steel body panels. You know, the original angular design was one of Cybertruck's most defining features, but also one of the most controversial. That aggressive styling is a big reason why the vehicle hasn't rolled out more broadly in global markets. In regions like Europe and Asia especially, those sharp edges are seen as a potential danger to pedestrians and could cause more severe damage to other vehicles in the event of a crash. So, this design change could make the Cybertruck far more acceptable, especially in markets with strict road safety regulations. What do you think about a less angular Cybertruck? Drop a comment below. One of the key factors in reducing production costs is the battery system. The smaller Cybertruck version is expected to use a battery pack with reduced capacity, dropping from 123 kilowatt-hours down to somewhere around 75 to 100 kilowatt-hours. Surprisingly, though, the range won't drop that much. The new Cybertruck should still be able to go over 300 miles. Why is that? The simple answer is that a smaller battery pack doesn't just lower costs, that also significantly reduces the weight of the Cybertruck. Thanks to adjustments in both vehicle size and battery configuration, this version is expected to weigh around 4,500 to 5,000 pounds, with a lighter frame structure. The more weight you cut, the less battery capacity you need to maintain solid range. What we don't yet know is whether Tesla will continue using its 4680 battery cells in this smaller version. As of now, Tesla uses 4680 cells across all Cybertruck variants. While these are known as one of Tesla's in-house battery innovations, they're still relatively expensive to produce. That's why we can't help but question whether Tesla will really stick with 4680s for a more budget-friendly version of the Cybertruck. What do you think? Should Tesla consider switching to a different type of battery for the smaller pickup? As for the powertrain, the compact Cybertruck version will likely offer just two options: a single motor setup producing around 300 to 350 horsepower, and a dual motor configuration delivering about 400 to 450 horsepower. Acceleration from 0 to 60 miles per hour is expected to fall between 4.5 to 6 seconds, powerful enough to compete with today's mid-size pickup trucks. Removing the tri-motor option not only helps cut costs, but also simplifies the drivetrain system, making it easier and more affordable to manufacture. Finally, towing and payload capacity on the compact version will definitely be lower compared to the original Cybertruck, mainly due to the smaller battery and lower-powered motors. This version is expected to tow between 7,000 and 8,000 pounds and carry a payload of 1,500 to 2,000 pounds, which is more than adequate for everyday tasks and shorter trips. Not just the battery and motor, interior designs and premium features may also be simplified in this version. These are some of our predictions. As we all know, the large 18.5-inch touchscreen is a standout interior feature of the Cybertruck, displaying the speedometer, driver assist systems, infotainment, and more. Its sharp graphics and intuitive menus make the Cybertruck's screen easy to navigate and impressive to show off to friends. However, a smaller Cybertruck doesn't need such a large screen. A display under 15 inches like the one in the Model Y would be more than enough. The 15-speaker audio system could be reduced to 10 speakers. The 9.4-inch rear screen may be eliminated. There would be no steer-by-wire system, and it might use standard non-electric leather seats. The lighting could be monochrome, and the window glass simplified. No more shatterproof windows. Sound insulation would likely be less advanced compared to the current Cybertruck models. With these adjustments, the compact Cybertruck is expected to be at least $20,000 cheaper than the current Cybertruck RWD. That would bring the price down to $49,990, or possibly even lower if Tesla achieves greater efficiency during production. At $49,990, the Cybertruck would easily compete with pickup models like the Ford Ranger or Toyota Tacoma. Its minimalist design with thoughtfully removed features would help Tesla expand its market and appeal to a broader customer base, especially those who don't need a full-sized pickup. This is what we predict could happen with the smaller version of the Cybertruck. While these predictions may turn out to be right or wrong, they're certainly not out of the realm of possibility, especially considering that Tesla is well known for its ability to simplify things in order to cut production costs. Tesla doesn't have much experience in producing low-cost vehicles, but that's exactly the strategy we'll see more clearly when the Model 2 launches later this year, as mentioned during the Q2 earnings call. The Model 2 is expected to be an affordable car that could help turn things around for the company amid declining sales, and as Tesla falls behind BYD. Yeah, this is probably the most accurate depiction we've seen of the Model 2's design so far. Although Elon Musk said it would resemble the Model Y, it's clear that it doesn't look exactly the same. According to what's been revealed about this vehicle, it's expected to be 30% to 35% cheaper than the Model Y, which would make it one of the most affordable electric cars you can buy. We already know some details, not everything, but there's some pretty interesting data coming out of China that gives us a glimpse of what the new Model Y will and won't have. A prototype that was photographed shows the car has a front bumper camera, confirming that it will support full self-driving. The headlights have been moved up from their current lower position on the Model Y, and the full-glass panoramic roof is being eliminated. Some people might not be used to this design, but it's actually quite interesting, although this change may not be the most cost-effective move for the Model 2. It's a major shift, as Tesla will now have to build the entire roof out of steel instead of glass. So yes, that's a big change. No more panoramic glass roof. Of course, the rear screen for passengers is also being removed. We don't think that's really necessary in a budget-friendly car. After all, earlier versions of the Model 3 and Model Y didn't have rear screens either, so this is probably the right call. What about the battery for the Model 2? It looks like it'll use lithium iron phosphate batteries, with a pack size of just 53 to 55 kilowatt-hours. The driving range will likely drop to around 220 miles with the smaller battery pack. We don't think Tesla will go below 200 miles of range. In fact, the range could end up being higher than 220 miles, since the vehicle will use smaller wheels and have a lighter overall weight. This could increase range by around 5%. So, the range of this more affordable version of the Model Y, presumably the Model 2, could reach up to 240 miles by our estimate. That would be a real benefit for users. Most people don't actually need large wheels on a car like this, so that would be a big plus. There's no rear light bar like on the current Model Y, and this is still a four-door vehicle, with dimensions not drastically different from the Model Y. Essentially, the Model 2 will still be a crossover. The desire to buy the car is very high. It's just people don't have enough money in their bank account to buy it. Literally, that is the issue. Not a lack of desire, but a lack of ability. So the more affordable we can make the car, the better, Elon Musk said during the earnings call. Driving sales through more affordable products is crucial, especially as Tesla faces declining demand due to increasing competition and changes to government incentives, at least in its home market, the United States. Tesla's total revenue in Q2 2025 dropped 12%, year over year to $22.5 billion, while total vehicle deliveries fell 13% compared to the same period last year. In addition to developing new, more affordable and compact vehicles for the mass market, Tesla is also expected to shock the entire industry with the Optimus robot, more specifically, Tesla Optimus version 3. Over the years, Tesla has continuously improved its humanoid robot, from the early versions to the current Optimus Gen 2. Earlier this year, Elon Musk revealed that Tesla aims to produce at least 5,000 Optimus units in 2025. However, during the Q2 2025 earnings call, Musk clarified that once mass production begins, Optimus will feature the version 3 design, which is different from the current Gen 2 Optimus. Musk expressed strong optimism about the potential of Optimus 3, describing its design as exquisite and predicting it will eventually become Tesla's most important product in the long run. He emphasized that the V3 design is nearly flawless, requiring no fundamental changes, and includes all the necessary degrees of freedom to handle complex tasks. Although Tesla has not yet revealed official images of Optimus 3, many expect the robot to feature a modern appearance similar to the slim humanoid concept model introduced in 2021. If so, it's poised to become one of the most advanced tech products on the market. During the Q2 earnings call, Musk emphasized that Optimus 3 will have more degrees of freedom, allowing the robot to move and operate more like a human, with the ability to perform around 3,000 useful tasks. Optimus 3, is expected to far surpass the Gen 2 version. The new design will be lighter and is expected to move faster, thanks to the use of lighter materials or improvements in joint structure. Version 3 will also feature voice support from Grok and display useful status updates and user-requested information. Musk highlighted that every component of Optimus, from the motors and gearboxes to the sensors, has been custom designed based on fundamental physics, as no off-the-shelf parts could meet Tesla's requirements. The company is also leveraging AI technology from its full self-driving system to train Optimus, enabling it to move fluidly, avoid obstacles, and build environmental maps on its own. Regarding production plans, Musk said Tesla will begin building Optimus 3 prototypes by the end of 2025, with mass production ramping up in 2026. He predicted that Tesla could be producing 100,000 robots per month by 2030, though he acknowledged that the first 1 to 2 years will be challenging due to supply chain issues or internal errors. As for pricing, Musk has previously mentioned a target price of $20,000 for Optimus, though some estimates suggest Optimus Viv 3 could cost up to $50,000. Still, with its ability to carry out thousands of tasks, from cleaning and elder care to factory assistance, Optimus could offer major savings on labor costs. For example, a worker in the U.S. earns about $35,000 per year, while Optimus only needs a 20-minute charge to run for 8 straight hours. Above all, Optimus 5.3 is not just a piece of technology. It has the potential to fundamentally change the way people work and live. By automating repetitive or dangerous tasks, Optimus could reduce reliance on manual labor, boost productivity, and lower costs. However, it also raises concerns about employment, as industries like manufacturing, healthcare, and warehousing could face disruption. Even so, Optimus also opens up new opportunities in fields like robotics research, development, maintenance, and creative industries. ICE cars are 100% going away at some point. Maybe not tomorrow, maybe not even in the next few years. But yeah, once most countries start banning emission vehicles, it's game over. In other words, EVs are what the world is betting on for the long haul, even if, right now, they still cost more than ICE cars. But why are EVs so expensive? Why do so many people still push back against them? Well, the answer's pretty obvious. The battery. Batteries can make up nearly 40% of the total cost of an EV, and right now, most of those batteries are lithium-based. In fact, about 75% of the EVs on the road today run on lithium batteries. Here's the undeniable truth. For years, the world has been living under the reign of lithium-ion. It's everywhere, not just in EVs, but in your iPhone, your AC remote, your kids' toys. You name it, it's lithium-powered. But believe it or not, that's about to change. In the not-so-distant future, lithium might be completely replaced, at least in EVs. Why? Because there are tons of new battery technologies being developed around the globe, all with one mission: to kick lithium off the throne. And if you hate Tesla, you might want to brace yourself, because this next part is only going to make you hate them more. Once again, Tesla is about to drop a battery that could change the game. We're talking about something with up to 3 times the energy density of what they're using now. Almost nobody knows what just happened at Tesla, but this new battery, it could completely rewrite the company's future, and it might just be Elon Musk's biggest gamble yet. How powerful is it? How cheap could it get? These new batteries have clearly been in the works at Tesla for a long time. Even though the company has tried to keep it under wraps, internal leaks have made it obvious that Tesla wants people to know they're doing something big to push EV battery technology forward, especially for the affordable model set to launch in the near future. What's mind-blowing is that this new battery is made from materials that are far more common and much cheaper than lithium, yet it delivers 3 times the energy density of current lithium-ion batteries. Of course, no technology is perfect from day one. There are still a few hurdles to overcome. But overall, this battery is already superior in nearly every way. And once those final challenges are solved, this won't just compete with lithium. It could replace it entirely, ending lithium's reign once and for all. Yeah, this is the Tesla A1 battery, the company's first-generation aluminum-ion battery. Put simply, aluminum-ion batteries work much like lithium-ion batteries, but instead of using lithium ions as the charge carriers, they use aluminum ions. Each aluminum ion cell has three main components. A node typically made from aluminum metal, where the aluminum ions originate. Cathode, built from materials such as graphene or metal oxides to store those ions. Electrolyte, a liquid solution that allows aluminum ions to flow back and forth between the two electrodes. The key difference lies in the very nature of aluminum. Each aluminum ion carries 3 positive charges, while a lithium ion carries only 1. This means aluminum can move 3 times more energy per ion, boosting energy density without relying on rare materials or complicated manufacturing processes. In theory, this allows aluminum-ion batteries to store far more energy in the same amount of mass compared to traditional lithium-ion batteries. And now, the real-world results are starting to prove that potential. Reports suggest that the aluminum-ion battery technology Tesla is testing has already reached energy densities of over 700 watt-hours per kilogram, a figure powerful enough to completely disrupt the battery industry. To put that into perspective, if you equipped a Tesla with this battery, it could travel over 700 miles. That's about 1,126 kilometers on a single charge. Some estimates even push that number closer to 1,000 miles, around 1,600 kilometers per charge. That's a leap so massive that even the most optimistic EV enthusiasts would have a hard time believing it. Which raises one big question. How did Tesla pull off such a giant technological leap? A clear example really shows the difference. Right now, the Tesla Model 3 long-range AWD can go about 346 miles on a 79 kilowatt-hour NMC battery. And those NMC cells only have an energy density of around 180 to 200 watt-hours per kilogram. But aluminum-ion batteries, they hit about 700 watt-hours per kilogram. That's roughly 3.5 times higher. What does that mean? If you swapped out the Model 3's NMC pack for an aluminum-ion pack of the same size, that car could easily hit around 1,038 miles, over 1,600 kilometers on a single charge. That's not just pushing past today's limits. It's rewriting the standard for the entire EV industry. And while lithium-ion batteries are still widely used today, as we mentioned earlier, they haven't seen any truly groundbreaking leap in energy density for decades. Lithium-ion has been stuck at roughly 200 watt-hours per kilogram for years. Even with Tesla's most ambitious efforts, their 4680 cells, energy density has only climbed to about 275 watt-hours per kilogram, which simply isn't enough to change the game. And that's exactly why there's room for something new, and aluminum-ion is stepping in as one of the most promising answers we've ever seen. That said, we've got to be realistic here. Sure, aluminum-ion batteries can hit 700 watt-hours per kilogram at the cell level, but once you build a full battery pack with the casing, cooling system, and all the extra hardware, that number comes down. And that's exactly why optimizing the pack's size is so critical. It's the key to keeping performance high while also cutting down production costs. So instead of that theoretical 1,000-mile range, a more practical number would be closer to 700 miles. But honestly, that's still enough to blow past anything on the market today. Now, if we look at Tesla's 4680 battery, it's still one of the most advanced battery technologies in the world. But here's the catch. This incredible battery is only showing up in high-end cars. Right now, it's basically limited to the Cybertruck, and even the cheapest variant starts at $69,990. And that raises a big question. Can Tesla actually bring this tech down to more affordable cars like the Model 3 or Model Y anytime soon? The answer, at least for now, seems to be a hard no. The reason's pretty straightforward. Lithium prices keep skyrocketing, which is driving up battery production costs like crazy. Since pretty much all of Tesla's current batteries, LFP, NMC, you name it, including the 4680, still rely heavily on lithium. Using the 4680 for cheaper cars is basically a pipe dream. Elon Musk has talked up a storm about launching a compact electric car for around $25,000. But let's be real. That plan's been stuck in neutral for over 4 years. Word is it's finally dropping this November, and no shocker here. Tesla's almost definitely going with LFP batteries for that one. While an energy density of 700 watt-hours per kilogram is certainly impressive, That's not the only reason Tesla is so committed to aluminum-ion battery technology. As Elon Musk has pointed out, the bigger problem is the ever-escalating cost of lithium-ion batteries. This is largely due to the soaring demand for lithium and limited supply, which has led to overmining and ever-increasing prices. This has not only put pressure on the entire EV industry, but has also made it difficult for manufacturers like Tesla to create more affordable models for consumers.
So the price of lithium and all the raw materials and the battery cells went crazy. It doubled. The price of cells doubled. Price of lithium, I think, went up at almost five-fold or 500%. Went up crazy numbers.
Right now, Tesla's using LFP and NMC batteries for the Model 3 and Model Y, while the Cybertruck's rocking the 4680 cells. All three rely on lithium, and they also use pricey materials like nickel and cobalt. A quick Google search will tell you these are some of the most expensive materials for battery production. Even Elon Musk has admitted that the 4680 batteries are actually pricier than traditional ones, since they're packed with all three: nickel, cobalt, and lithium. So, even though the 4680 is cutting-edge tech, the cost is still a major hurdle keeping Tesla from slapping it into more affordable models. If you know anything about the metals in Earth's crust, you probably know aluminum is the most common one. It makes up about 8.13% of the entire crust. Bauxite, the main ore used to produce aluminum, is found across dozens of countries. With global reserves sitting at roughly 1.59 billion tons, aluminum is not only far easier to source than lithium, nickel, or cobalt, but it's also way less vulnerable to geopolitical risks or supply chain disruptions. And that's exactly the golden opportunity for Tesla to slash battery costs like never before. According to the data we've seen, aluminum-ion batteries could cost as little as $40 to $65 per kilowatt-hour once the tech hits full commercial scale. And that number could drop even further if Tesla ramps up large-scale production, something they've already proven they can do with their massive battery lines at the Nevada Gigafactory. Of course, Tesla doesn't regularly disclose details about production costs, and so far they've never officially revealed the actual cost of the batteries they use. However, based on independent analyses, it's estimated that batteries typically account for about 25 to 40% of a Tesla's total production cost, depending on the battery type, vehicle model, and specific configuration. For example, with the Tesla Model Y priced between $45,000 and $60,000, its battery pack ranges from 67 to a tantadue kilowattora. Applying an average NMC battery cost of around $139 per kilowatt-hour, the battery pack's cost would be approximately $9,300 to $11,400, equivalent to 19 to 25% of the vehicle's total value. However, if replaced with aluminum-ion batteries costing only $40 to $65 per kilowatt-hour, this figure would drop significantly to just $2,700 to $3,000, $5,300. This means Tesla could substantially reduce selling prices, creating a real opportunity to bring affordable EVs to more people. When Elon Musk chooses to invest in a new battery technology, performance and energy density are always top priorities. However, the most critical factor is scalability. No matter how powerful a battery is, if it's too expensive and only suitable for luxury vehicles, it won't drive real change. That's why aluminum-ion batteries are expected not only to deliver superior performance, but also to solve the production cost challenge, a key factor in enabling Tesla to lower electric vehicle prices and shed its reputation as a company that only sells EVs for the wealthy. Beyond that, aluminum-ion batteries have an advantage that even the most advanced lithium-ion batteries can't match: charging speed. While a modern lithium-ion battery takes at least 20 to 30 minutes to charge to 80%, aluminum-ion batteries can reach a full charge in just 5 minutes, and notably they do so without overheating. This could eliminate one of the biggest barriers preventing wider adoption of electric vehicles. The ultra-fast charging capability of aluminum-ion batteries stems from their fundamental properties. Aluminum ions move through the electrolyte 3 times faster than lithium ions. As a result, Charging is not only faster but also maintains optimal performance without stressing the battery's structure. More importantly, these batteries offer superior thermal management, effectively addressing the overheating issue, a critical weakness of traditional lithium-ion batteries. Thanks to these advantages, aluminum-ion batteries are not only faster to charge but also safer and more durable over the long term. Additionally, one of the chronic diseases of lithium-ion batteries, the formation of metal dendrite crystals, is virtually non-existent in aluminum-ion batteries. Dendrites are metal crystals that form during charging, potentially piercing the separator, damaging the battery's structure, and causing serious issues like reduced performance or even fires and explosions. With aluminum-ion batteries, the release of aluminum ions occurs much more uniformly and stably, nearly eliminating the risk of dendrite formation. Studies from reputable institutions like Stanford University have shown that these batteries can withstand tens of thousands of charge-discharge cycles without this issue, a massive leap forward compared to traditional lithium-ion batteries. While conventional lithium-ion batteries typically endure around 2,000 charge cycles before dropping to 80% capacity, equivalent to 4 to 8 years of daily use, some independent studies suggest aluminum-ion batteries can achieve up to 15,000 cycles. This means that with proper use and maintenance, an aluminum-ion battery could last up to 35 years, a true game-changer compared to current battery technologies. The reason for this remarkable durability lies in the physical and chemical properties of aluminum. Physically, aluminum is an exceptionally robust material, widely trusted in modern car frames for its strength and resistance to deformation. Chemically, aluminum is far more stable than lithium. While lithium readily reacts with oxygen and water, leading to material degradation over time, aluminum forms a natural oxide layer when exposed to the environment. This oxide layer acts as a shield, preventing corrosion and maintaining the stability of the anode, thereby extending the battery's lifespan far beyond existing technologies. This is the key point. Tesla isn't just developing a battery that charges faster. It's creating one durable enough to potentially outlast the electric vehicle itself, making battery replacement a thing of the past. But that's not all. Another persistent issue with lithium-ion batteries is the risk of fire and explosion. Lithium batteries can ignite if impacted or overcharged, and the resulting smoke is not only toxic, but also extremely difficult to extinguish. Despite years of research and improvements, this risk has not been entirely eliminated. In contrast, aluminum-ion batteries are nearly immune to this danger due to their stable chemical properties and superior heat resistance, setting a new safety standard for the EV industry. Additionally, aluminum-ion batteries offer a strategic advantage: superior recyclability. Aluminum is the most abundant metal on Earth, and if this technology is widely adopted, it could significantly reduce reliance on expensive and hard-to-mine metals like lithium, nickel, or cobalt. Laboratory experiments have already shown that up to 80% of aluminum fluoride salts can be recovered, with expectations of even higher rates at industrial scale. Notably, the solid aluminum foil from these batteries can be reused almost directly after cleaning, making aluminum-ion batteries one of the most sustainable and environmentally friendly solutions the industry has ever seen. However, no technology is perfect from the start, and aluminum-ion batteries are no exception. A notable challenge is their reduced performance in low-temperature environments, which currently limits their use in colder climates. Nevertheless, this is not an insurmountable barrier. Leading research teams worldwide, including Tesla, are intensely focused on addressing this issue to ensure that aluminum-ion batteries not only excel in performance, but are also ready for all real-world conditions. Currently, aluminum-ion batteries have not been widely publicized and are rarely mentioned in mainstream media. However, if Tesla can successfully commercialize A1 battery cells and integrate them into more affordable vehicle models, it would not only be a technological breakthrough, but also a game-changer for the entire electric vehicle industry. According to internal sources, Tesla plans to produce all aluminum-ion batteries in the U.S. at a new expanded facility adjacent to Giga, Nevada. The production line is expected to begin operations by the end of this year, once all equipment is installed and fully calibrated. In theory, the lifespan of aluminum-ion batteries is truly impressive. No battery lasts forever, but with the potential to achieve up to 15,000 charge cycles, aluminum-ion batteries could last 35 years or more, a figure that lithium-ion batteries cannot come close to matching. This makes them an ideal choice not only for electric vehicles but also for large-scale energy storage systems. More importantly, in terms of cost, researchers believe that when mass-produced, the price of aluminum-ion batteries could be comparable to, or even lower than, current lithium iron phosphate batteries, a possibility that was once considered nearly impossible. Over the past 2 years, lithium prices have been a roller coaster, with brief dips followed by sharp spikes. This year, they surged to $9,200 per ton. The issue isn't just the cost, but also the scarcity. Global lithium reserves are estimated at around 89 million tons, nearly 18 times less than aluminum. More concerning, the majority of these reserves are concentrated in just 4 countries. China holds about 16.5%, with the rest primarily in the lithium triangle of Chile, Bolivia, and Argentina. With such concentrated supply, lithium prices are not only high, but also vulnerable to geopolitical factors. This coming October, Tesla will launch the Model 2, an affordable car priced at just around $25,000. But behind that attractive price tag lies an incredible technological story. Tesla will manufacture the Model 2 using a massive Giga Press machine, capable of exerting up to 50,000 tons of pressure. According to Elon Musk, these cars will be sold at an affordable price point, which means demand will be enormous. Tesla needs a machine that can produce fast enough before facing millions of orders. This isn't just any ordinary machine, it can create an entire car in just a matter of seconds. Yes, you heard that right. Let's dive into how Tesla is building a $25,000 car right now. For many from the generation that witnessed the golden age of classic Chevrolets, busy assembly plants, and the sound of welding machines ringing out day and night, the idea of casting an entire underbody in just a few seconds may sound like pure science fiction. But Elon Musk and Tesla are making it a reality.
Like real fast. And then I guess maybe we need to just get even bigger casting machines. Sure, why not? Down, yeah, let's 50,000 tons. I think it'll be able to produce a car ultimately in less than 5 seconds. Can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
What's remarkable is that it all started with something incredibly ordinary. One day, Elon Musk was looking at a Hot Wheels Model S toy car made using die casting or injection molding, which is why they're cheap and widely available. At that moment, Musk had a thought. Why doesn't Tesla do the same with the Model Y? What seemed like a casual question ended up planting the seed for an industrial revolution. Shortly after, Elon Musk began searching for a partner that could build a machine big enough to bring this idea to life. 5 companies flat out said no. Only one, Idra Group, a company in Italy, dared to respond with a simple maybe. And with that, maybe, the journey to change the future of car manufacturing began. It all started with the 6,000-ton Giga Press, which Tesla used to cast the rear underbody of the Model Y. This machine replaced more than 70 individual parts with a single solid piece of aluminum, dramatically simplifying the assembly line. Next came the 9,000-ton Giga Press, specially designed to cast the body of the Cybertruck, a vehicle massive in size and made from stainless steel. The 9,000-ton press was already hugged, but what about the upcoming 50,000-ton Giga Press? Just how powerful will it be? And how can it possibly cast 5 Model 2's underbody at the same time? Tesla's affordable new car, unofficially known as the Model 2, features a compact design with short front and rear overhangs. Compared to the Model Y, which has over 200 structural components, the Model 2 uses only about 80, a reduction of more than 60%. This dramatically simplifies assembly and significantly cuts production costs. Tesla used the 6,000-ton Giga Press to produce the rear underbody of the Model Y and the 9,000-ton press to cast parts of the Cybertruck's structure. Both machines have proven highly effective cutting costs, speeding up production time, and delivering high-performance vehicle frames for the Model Y and Cybertruck. So you might be wondering, if the Model 2 is smaller than the Model Y, why doesn't Tesla just use the 6,000-ton Giga Press to build it? Why go all the way up to a machine with 8 times the clamping force? It's a fair question, but here's the explanation. At its core, the Giga Press is a high-pressure die casting machine. Die casting has long been an essential part of the auto industry's history, used to create critical parts like engine blocks, transmission housings, and front or rear vehicle subframes. However, up until now, Tesla's 6,000-ton and 9,000-ton Giga Presses have only been able to cast sections of a vehicle's frame, not the entire thing. But Tesla has bigger ambitions for the Model 2. It wants to cast the entire underbody of the car in a single shot. Naturally, the existing machines aren't powerful enough to pull that off. That's why Tesla needed a much larger machine with greater clamping force and multiple molds operating on a single press. And that's exactly why Elon Musk ordered the 50,000-ton Giga Press. While other automakers, especially in China, have tried to imitate Tesla's approach, no one has been able to keep up. Why? Because Elon Musk keeps pushing the limits, continuously upgrading the machine itself. The Giga Press manufacturing process isn't just an innovation in the EV industry. It's a major leap forward in both technology and production efficiency. At the heart of this technology is the process of melting an aluminum alloy at extremely high temperatures inside an industrial furnace. Once the aluminum reaches a molten state, it's poured into a precisely engineered metal mold shaped to match the part being produced, such as a vehicle frame. The Giga Press then applies immense pressure, ensuring that the molten aluminum fills every tiny detail of the mold, leaving no defects behind. What's critical here is achieving perfect balance. If the casting is done too quickly, air bubbles can form. If too slowly, the aluminum begins to cool before filling the entire mold. That's why the Giga Press relies on a highly controlled cooling system to ensure that the solidification process happens evenly and consistently. This precision not only guarantees high quality, but also results in durable, structurally sound components. Once cooled, a robotic arm automatically removes the part from the mold, trims off any excess material, and transfers it to a quality control station to ensure every detail meets exact standards. One of the key advantages of the Giga Press is its ability to reduce vehicle weight, increase structural rigidity, and improve overall performance. By casting a single large part instead of welding together dozens of smaller components, Tesla saves time, minimizes errors, and boosts production efficiency, pushing EV manufacturing into a new era. Today, Giga casting technology is no longer exclusive to Tesla. Major automakers like General Motors, Hyundai, Volvo, Zeekr, and XPeng have all made significant investments in their own Giga casting systems. Among them, XPeng has made headlines by installing a 16,000-ton Giga Press, an advanced piece of technology that's hard to ignore. However, Tesla remains the pioneer, pushing the boundaries of this technology even further with the upcoming 50,000-ton Giga Press. A bold move that no one saw coming. When Elon Musk first mentioned the 50,000-ton Giga Press, we all had the same questions. How massive will this machine be? Where will Tesla install it? How long will setup take? And how on earth can it produce tens of thousands of Model 2 units each week? With the launch of the 50,000-ton Giga Press, Musk made it clear. This new production line will operate at a speed so fast that humans won't be able to get close to it. Everything will be fully automated and, quite frankly, dizzying to witness. Every step of the process, from pouring the molten metal, cooling the mold, to extracting the finished part, will be fully automated. And here's the most jaw-dropping part. Each production cycle will take only about 5 seconds. That means a full vehicle underbody could be completed in the time it takes you to blink a few times. With the 50,000-ton Giga Press, it's easy to imagine a colossal machine roughly the size of a 3- or 4-story building laid on its side. Tesla will need to build a dedicated facility just to house it, likely requiring a heavily reinforced concrete foundation dug several meters deep to support the machine's immense weight. To put it in perspective, the 50,000-ton Giga Press exerts about 8.3 times more pressure than Tesla's 6,000-ton machine and 5.5 times more than the 9,000-ton version. It's estimated that this machine could be around 65 feet long, 39 to 49 feet high, and 33 to 39 feet wide, with a total weight exceeding 3,000 tons. While the operating principles of the 50,000-ton Giga Press remain similar to those of the 6,000 and 9,000-ton models, it features major advancements in scale and output. For example, whereas traditional die casting machines typically operate with a single mold, the 50,000-ton version will have at least 5 molds, allowing it to cast 5 vehicle underbodies in a single cycle. The process begins with material preparation. Tesla melts down fresh aluminum ingots along with recycled aluminum from previous casting cycles in a furnace, reaching temperatures around 1,562 degrees Fahrenheit. Once molten, surface impurities are removed, and the purified liquid metal is transferred through heated pipelines into a sealed holding furnace, where temperatures are maintained between 1,382 degrees Fahrenheit and 1,562 degrees Fahrenheit. The Giga Press uses a 2-furnace system to handle the aluminum alloy. One furnace melts the aluminum, powered by natural gas, while the second furnace, heated electrically, keeps the molten metal at a consistent temperature for casting, as mentioned above. The interior of the holding furnace is filled with nitrogen gas, which helps prevent oxidation in the molten aluminum and maintains a stable temperature. Additionally, argon gas, a rotary degassing machine, and a silicon carbide filter are used to remove impurities and particles larger than 25 microns, ensuring the metal's high quality. Once the material preparation is complete, the next step is mold preparation. Before each casting cycle, the Giga Press applies a thin, even layer of lubricant to the mold surface using a robot that sprays about 35 milliliters of soybean oil, much like greasing a baking pan, to make it easier to remove the finished part afterward. Next, a vacuum system activates to remove air from the mold cavity, and then the molten aluminum is transferred from the holding furnace into the Giga Press's injection chamber. Here, the liquid metal is injected into the mold cavity by a high-speed piston. The piston itself is lubricated with about 8 milliliters of oil before each injection to ensure smooth and efficient operation during the casting process. The casting process used by Tesla's 50,000-ton Giga Press is not only advanced but also far more complex than standard die casting machines. Due to its enormous size and power, this press demands extremely tight control at every stage. One of the biggest challenges is that the molten aluminum must travel a longer distance than in smaller machines, increasing the risk of defects during casting. If the molten aluminum is injected into the mold too quickly, there's a high risk of air bubbles forming, which would weaken the final part's strength and durability. Conversely, if the injection process is too slow, the aluminum may begin to cool before completely filling the mold, resulting in incomplete or uneven parts. That's why the 50,000-ton Giga Press casting system must operate with extremely high precision. Every movement, every second, needs to be carefully controlled. After the aluminum is injected, it remains in the mold until it fully solidifies. The rough casting is ejected from the mold when it reaches about 752 degrees Fahrenheit and is immediately transferred to a cooling bath to rapidly reduce its temperature from 752 degrees Fahrenheit down to around 122 degrees Fahrenheit. This rapid cooling process not only effectively cools the material, but also helps eliminate certain defects that might form during solidification, while improving the aluminum's mechanical properties such as strength and hardness. Once the casting has finished cooling, the mold opens and is cooled down to around 365 degrees Fahrenheit. A robot, then, thoroughly cleans the mold, removing any impurities or leftover material, preparing it for the next casting cycle. This ensures that each subsequent cycle runs smoothly without any interference from leftover debris or contaminants from the previous cycle. Typically, a new casting cycle begins just 1 to 2 minutes after the previous one finishes, keeping the production line operating at maximum speed and efficiency. Any excess metal left after casting is cut off and recycled to be melted down again in the next batch, ensuring maximum efficiency and material savings. After the casting process is complete, the final product undergoes quality inspection using X-ray imaging, which accurately detects strength and any potential structural defects, ensuring the part meets the strictest standards. One of the biggest challenges during casting is preventing the mold from separating under the extreme clamping force applied when injecting molten aluminum. That's why the die casting machine must exert very strong clamping force to keep the mold tightly sealed and stable throughout the entire process. With the 50,000-ton Giga Press, this clamping force is exceptionally high, far beyond that of conventional casting machines, to ensure the mold stays perfectly aligned and can withstand the enormous pressure without deforming or breaking. This not only guarantees precise casting, but also ensures the quality and durability of every part produced.
So I mean, we got to jam the liquid metal in, cool it down real fast.
According to Elon Musk, to achieve outstanding casting speed and efficiency, Tesla had to design a super-fast cooling system, an intelligent mold release mechanism, and an AI-powered automated quality inspection process, a technological combination that no other automaker has attempted at this scale. This innovation is not only a technological breakthrough, but also a turning point in automotive manufacturing. Using AI to automate quality checks and employing smart mold release mechanisms optimizes production, minimizes errors, and ensures the highest product quality. This also marks the first time in the automotive industry that Tesla has shifted to a production model similar to electronics manufacturing, fast, lean, and space-efficient. This model not only reduces production time and costs, but also opens the door to mass-producing high-quality automotive parts at unprecedented speeds, creating a new future for the global automotive industry. Besides owning the new 50,000-ton Giga Press, Tesla's VP, Lars Moravi revealed that the rear Giga casting of the new Model Y has been significantly redesigned. The rear frame is now about 15 pounds lighter than the previous version, while machining time has been reduced by over 50%. This weight reduction of up to 15% not only improves the vehicle's performance and range, but also enhances the structural rigidity of the rear, reducing body twist during sharp cornering and delivering superior handling. In an interview, Lars Moravi shared that Tesla's Giga casting process has seen major improvements since 2020. Specifically, Tesla now uses advanced cooling technology, where cooling channels follow the shape of the mold, cutting the cycle time from 170 seconds down to just 75 seconds on the 6,000-ton machine. As a result, the Model Y is not only lighter but also more precise and consistent, boosting production efficiency and product quality. Surprisingly, Tesla has not applied Giga casting to the front section of the new Model Y, a rather unusual move given that Tesla pioneered this technology. However, Lars Moravi explained that most current Model Y production lines still use stamped sheet metal for the front, rather than Giga casting, due to technical and economic factors that have so far limited the expansion of this technology to other parts of the vehicle. Tesla has unveiled its 6-seat Model Y variant in China, known as the Model YL. This new variant of one of the world's best-selling vehicles comes with a longer wheelbase, adjusted C-pillar design, and most importantly, a 6-seat interior layout. The addition of a longer wheelbase and a more spacious third row is a fantastic addition for the Model Y's family utility and positions this variant as sort of a mini Model X. But let's compare the sizes to really know how this new Model Y compares to a Model X. The defining feature of the new Model YL is its 6-seat configuration. This layout has previously been exclusive to the larger and more expensive Model X. While Tesla has offered the Model Y in a 7-seat configuration before, the third row was much too small to be utilized by anyone but small children. While this Model YL is slightly smaller than the Model X, it doesn't necessarily mean that it's smaller inside. The Model X features a much larger front end than the Model Y, accounting for several inches. When you line up the front wheelbase of the Model X with this new Model Y, the vehicles are almost exactly the same length. Tesla has designed this Model Y to be a bit more compact and efficient than the Model X, and likely much cheaper, while featuring the well-loved design of the new Model Y. Above all, from our perspective, the 50,000-ton Giga Press sets a new standard for speed, efficiency, and cost. With the ability to cast the entire chassis of the Model 2 in under 5 seconds, this machine not only redefines EV manufacturing, but also puts unprecedented pressure on Chinese automakers. By reducing over 60% of structural parts and eliminating hundreds of robots from the assembly line, Giga Press delivers superior simplicity and durability, enabling Tesla to produce affordable cars at an unprecedented scale. This creates a major challenge for competitors like BYD, NIO, and XPeng, who are striving to replicate high-pressure casting technology. The success or failure of Chinese manufacturers in producing low-cost EVs largely depends on their ability to catch up with this technology. Despite strong support from a huge domestic market and favorable policies, they still face technical barriers, such as replicating Tesla's proprietary aluminum alloys and many other technical factors known only to Tesla.